Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this Techstrong learning experience brought to you by AWS and LaunchDarkly. My name is Cody, and I'm the host of Techstrong Learning, and we do have an exciting presentation ahead. Before we begin, I do have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, perhaps you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude this live session today. If you'd like to engage with our panelists, you can do so using some features on the right side of your screen. The first feature is the chat tab, and I'd like you to start warming that up for us right now by letting us know from where you are joining us today. If you have any questions, we would like you to direct those to the Q&A tab, which can be found directly to the right of that chat tab. If you click over to the handouts, you'll see there are a couple of resources there for you, as well as a GitHub repo that will be used in a couple of demos throughout today. So if you would like to try to follow along or check that out, that is also available in the demos section, the handouts section. And of course, before we close out, we are going to be giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our presentation today. So to get us kicked off, we are going to discuss using LaunchDarkly feature flags in AWS Serverless. And I'm joined today by Brian Rinaldi, Developer Experience Engineer at LaunchDarkly, and Welly Shah, Principal Partner Solutions Architect for DevOps at AWS. So Brian and Welly, it's really nice to have you both on here with me today. Welly, do you want to go ahead and get us kicked off?
Yes, absolutely. Thanks so much, Cody. And Brian, good to see you again. Let's do this.
Good to see you too.
This is really two things that I have a lot of interest. One is feature flag itself and AWS serverless. Really like the idea about serverless. So this is two of my favorite subjects today. So let's get started. Again, my name is Welly. I'm a principal partner SA here at AWS. And today we'll talk about the first part is let's take a step back and look at what is this about serverless. What do I mean by that? When we look at studies that is done for the last couple of years, we saw that a lot of leaders says that a lot of their developer times is spent on operations and maintenance, and less is actually on the innovations. And that's for any leaders. And even if I'm a developers, I don't want to spend my times on operation and maintenance. I do want to try a couple new things, new innovations, and etc. But there are a couple of challenges around that, and there's many aspects of this. But for the sake of today's discussions, this is primarily about the removing undifferentiated heavy lifting on your infrastructures. And that's one reason why serverless adoption is growing fast. We see hundreds of thousands of customers in AWS today that use a serverless technology and services that we provide. For example, there are more than trillions of Lambda execution per month. And today we're going to specifically talk about the Lambda functions. So if you take a step back and look at the compute operational models across the AWS infrastructures, here you can see you can go from the most basic Amazon EC2 instance. You run your infrastructures, you run your virtual machines, you offload some of the responsibility to AWS, such as the physical hardware and also the boundary of the data centers and etc. And you have full control over operating systems and also patches and etc. And you can go all the way to the top. You see here a Lambda as a serverless functions, where the only thing you manage is your application code. You hand over the responsibility for maintaining these OS patches, for example, the networking part of that as well into AWS. Or you could be somewhere in between here, for example, using containers, or you may be using Fargate, which is actually a serverless containers. So you still have control over your applications, and you have control over other part of the managing the tags or the container itself, but you offload a lot of the infrastructure management to AWS. Now, if we talk about serverless and why that's important, this is started with the compute. We talk about using Lambda function or maybe Fargate. But the idea of serverless also touch another part of layers of infrastructures. As you can see in here, a data store. Amazon S3 essentially is a serverless object storage. You just drop the object right there, you drop the file, you don't have to manage the server, you don't have to care about scaling. Same thing with like RDS or Aurora serverless, and also DynamoDB. And when you look at integration, things such as queuing system, API gateway, notification systems, step functions, and more, a lot of these services is available, and then it's pretty much a serverless. If I really kind of take a couple decades of my own career in the past, when you build highly distributed systems, you do have to think about messaging systems. That's, in fact, it's actually another virtual machine running somewhere that has to wire up all of these messagings. But the idea with serverless is that you can do all of that by using the services and really focus on the key business function itself. And that's really where the innovation comes into the pictures. So if we kind of look like just Lambda functions, I wonder if how many of you today have used Lambda functions, and maybe some of you are completely new. Please put it on the chat. Like if it's if you are using Lambda today, are you already exploring Lambda perhaps, or you are maybe completely new to Lambda itself? I'd love to hear that. Now, if you look at here, for maybe some of you that new completely to Lambda, what does it actually do? It's essentially a compute services. You put your function, you put your code essentially, and then you have a way to invoke that code itself. So you can start that code. And the way you do that is by providing event source. It could be in JSON format, for example. This is your input essentially, and Lambda will give you a response. That response will be the output. Will be that could just be hello world, or it could be something that's more advanced, of course. And that's including, for example, you having Lambda to connect to the external services. So then that's open up the possibility. For example, your Lambda function could make a call to another AWS services, maybe to drop a file to the S3 buckets. Or maybe that Lambda function will invoke another Lambda functions as potentially. Or perhaps to also go to the external APIs, or maybe internal APIs as well. So really anything that you can code essentially, you can drop it to Lambda, and you can have invocation methods that works for you. Do see that a couple folks that already using Lambda. That's great. Not gonna take too much time in here, but again, for you that may be new to Lambda, there's a couple other way for you to also invoke that Lambda functions. So you can do, for example, a synchronous invocation of your Lambda. Typically, you do that by having an API gateway in front of it, and then you invoke that Lambda, and then you get the response back. Because this is synchronous, you want to make sure you have a good user experience. Typically, you want to try to avoid any long-running Lambda functions in this case. Or you can also do asynchronous processing. For example, you have a queue system, or you have a notification systems that push an push a new notification to the Lambda itself, and then Lambda will take and run any processings, and then you have to give some sort of like a callback, for example, to use it. There's a question, can Lambda be run on premises? No, today, no. Lambda itself, it runs as a part of AWS services itself, but Lambda can make a call to something that's on premises. So for example, if you have direct connect, for example, you can, which is a network connectivity between your AWS and your on-premises, then you can use Lambda to interface with maybe an API that sits on your on-premises. The other popular way to invoke Lambda functions is by using a streaming. Like we have a lot of data today, and a lot of those data can also invoke additional logics, essentially, right? So you can imagine you drop an item into your table in DynamoDB, and that actually will trigger the Lambda functions. And you can use that Lambda function to do certain things, similar thing with also Kinesis, where you can stream a message and use that to maybe enrich the message by using a Lambda function to change the schema of the message, for example. How you deploy Lambda and how you develop Lambda, it's very similar to any applications. So you can invoke Lambda through APIs, as I mentioned earlier, and you can use any of the development tools that you're familiar with, such as Cloud9, the Azure IDE, perhaps, or Visual Studio Code. And you can also use a framework such as the Serverless Access Model, or SAM. as a way for you to quickly develop your serverless Lambda functions. And also it allows you to do like a local testings and also deployment from that same framework itself. Okay, when we talk about development of the Lambda, we also need to talk about how you actually deploy that Lambda functions and how you release that new functions. Because the idea of a Lambda is that you offload a lot of this heavy lifting on your infrastructures because you want to innovate faster. When you say innovation faster, it means like maybe you do release every week, every hours, and etc. So let's talk a little bit about a couple ways for you to release your Lambda functions. This is one mechanism where you use two different Lambda functions essentially. So you have your old versions and your newer versions. And here you're using API Gateway to do a canary deployment. So you can set, for example, 90% of your traffic goes to the old Lambda functions, and you're slowly moving the traffic to the new Lambda instance. So this is the first way. Then there's also another way for you to look at this by using a Lambda version. So it's the same Lambda instance, but you can have multiple versions of your code. And so Lambda allows you to do that versioning. By doing that, then you can put an alias, for example, and you can set how many of your traffic goes to one version of the Lambda and when you're going to flip to a different version of that Lambda function. And all of this can be orchestrated either through like infrastructure as code, as part of your pipeline as well. And then that allows you to kind of push new changes and then get your customers or your users that using those Lambda function always pointed to the right versions or to the changes that you made. So kind of quick takeaway. Why customers want to use a serverless strategy. As you can see in here, there's a couple key components: the agility, the idea that you can quickly test your theory, you can quickly do prototyping without having to wait for an EC2 instance to be spun up, your VPC, and access to that instance itself. Then using Lambda, you can just drop your code, run some tests. If you don't like it, destroy it, and then try to the next new things, for example. From performance perspective, Lambda can be invoked in a couple milliseconds. There's a lot of performance tunings we can do, such as the new Lambda snapshot, for example. We're not going to discuss that today, but that's also additional venue that I highly encourage you to look at. You can do performance tuning based on numbers of memories that you want to add to those Lambda functions, CPU, and etc. And from the cost, it's very clear because when you run Lambda functions, you only pay for the actual compute time that Lambda function runs. So if your Lambda function runs for 300 milliseconds, you only pay for that 300 milliseconds. It really means that pay as you go, right? Up to the milliseconds, like a slice. So that means like you don't have a compute power that's sitting 24/7 that you need to scale in and out in order to kind of reduce the cost. All of those costs become like a flexible factors that based on the number of requests that's coming in. And from security, as I mentioned, like you offload a lot of these security patches on your operating systems and etc. to AWS by having it as part of the Lambda functions. And this is why customers like to use the serverless first strategy, especially if they're looking at doing a faster innovations in their organizations. But um, let's take a step back because I feel like when you talk about innovations, one thing is about using a technology such as serverless in order to help you with that. But the other pieces in here is about the operational consistency. How you ensure that you are not being coupled by a lot of dependency as you are releasing a new feature, for example. And here, I think the idea of marrying the feature flag into a serverless solution such as Lambda functions would be an interesting next step to discuss. And with that, Brian, do you want to take that away?
Sure. Thanks, Willie. All right, let me just quickly share my screen here because I'm going to show you some demos. So give me one moment here. All right, should be seeing my screen. Yep, looks like we're good. Okay, so now let's talk a little bit about feature flags. Um, If you want, drop in the chat if you've already used feature flags in any form. Do you have some solution currently, like maybe a homegrown solution, or you're already using a service like LaunchDarkly? I'd love to hear about that. But if you haven't used feature flags before, the kind of key thing to think about is that feature flags help you separate the concept of deploying and release. This means that just because a piece of code is deployed doesn't mean that it's actually running. So I could deploy a piece of code to production, but it might not actually be running in production because it's wrapped in a flag. So this helps remove risk from deploys and minimizes the risk of releases, because if a feature isn't working properly, once it's released, we can actually turn that off remotely without doing any kind of rollbacks or redeploys. This separation of deploy and release can really change the way you build and operate. So a tool like a feature management platform, kind of like LaunchDarkly, can take this even further by adding a ton of capabilities that a typical homegrown solution isn't going to have. So you'll get things like tools for governance. You'll get near instant flag updates. You get integrations with third-party platforms you're already using. All that's baked into the system, as well as things like experimentation and big segments and all kinds of other advanced features that typically aren't you won't find in a homegrown system. So these tools can help you change the way you build applications by allowing you to roll out features gradually, minimizing the risk of releases, and test in production via targeted rollouts of new features or canary launches. So, for instance, maybe your QA team can see a particular feature in production and test it there, but the rest of the world is completely unaware that that feature is there and running in production at all. So, all right. Sorry. So feature management doesn't just change the way you build things, it also changes the way you operate. It gives you tools to prevent incidents from escalating or to measure the success of a particular release. It can make complicated things like migrations less difficult, meaning your teams might be less hesitant to actually perform that upgrade on their software or take on a new tool that will actually make your applications better. By giving you these tools like kill switches and immediate feature flag updates, you can be sure that if there is ever a problem, you can flip that off, and you can roll these things out progressive manner and test them in production and be sure that when that feature is launched to everybody, you know that it's working. So, of course, for this to work well, it can't just exist in one layer of your application. It requires coordination of your front end, your back end, and your operations. So serverless computing is obviously going to come into play in this. This means that like integrating into things like Lambda or working with DynamoDB will actually be able to improve the overall success of your feature flag adoption across your application. So the good news is that LaunchDarkly offers more than 25 different SDKs for both the front end and the back end. So you can utilize feature flags within any part of your application, in all parts of your application, including any of the pieces that you're running on AWS Serverless Compute. We support all of the languages that AWS Serverless Compute supports. And our flag delivery network and SDKs are designed to minimize any performance impact on your application. So you can be sure that you can use flags safely and it won't impact your performance. Our targeting features are some of the most advanced, of any feature flag service, including, as we're going to look into, something called context targeting. I'll tell you more about that, but also things like big segments and experimentation allow you to do really advanced targeting, as well as workflows to control how all of that works. You've got a lot of tools for you built into the platform. So plus we have a ton of integrations, including integrations with basically all the tools you need within your AWS infrastructure. So if you haven't already heard of LaunchDarkly, we are used by thousands of customers, including many Fortune 500 companies. So you basically you can trust what we're offering. But let's get to the fun part, which is how do I actually add this to my code? So if you want to add this into AWS Serverless, well, once you have your LaunchDarkly account, it's just a matter of installing the appropriate SDK. I'm showing installing the Node SDK for using the Node.js runtime, but you would install the appropriate SDK for whatever language you're using into your application, and then you could start using it. And so we're going to look at how that's done. In my examples, I'm going to stick to serverless compute running in Lambdas. We are going to use the Node.js runtime, but keep in mind that this is going to work pretty much the same regardless of what environment you're running in or where you're installing the SDK. So to start the demo, I want to actually talk about Lambda layers a little bit here. If you haven't used Lambda layers before, I want you to keep, it's definitely a tool you really should check out, and it's the best way for you to manage installing a dependency like LaunchDarkly into Lambda. So I imagine you're going to have, not just a single Lambda, you're going to have multiple Lambdas handling different aspects of your application, and you don't want to have to manually install LaunchDarkly on each one of these individually, and then even worse, have to go when there's a new SDK version, I got to go update those individually one by one by updating the install on each of them and redeploying. Lambda layers give you a tool for managing dependencies that's much, much easier than doing it that way. So we are going to exit out of these slides, and we're going to talk a little bit about Lambda layers here. So in the handouts, you'll see there's a GitHub repo. All the code I'm going to talk about here is in that GitHub repo. There's not really much code involved here with Lambda layers, but basically what you're going to do, I have these different layers that I've already created for this application I've built. In this one, I'm just doing the Node SDK for LaunchDarkly. So what you're going to do is set up a folder with the name of the runtime. In my case, it's Node.js. And inside that folder, that's where I'm going to install the dependencies that I need in the layer. So in my case, I'd go into my Node.js folder, npm install LaunchDarkly Node SDK. And then what I'm going to do is then I zip this folder up. I don't zip the containing folder. I zip the Node.js folder up, and I'm going to upload that to AWS. So I'll show you where that is. So if you go to Lambda, you're going to go to layers. You'll see that I have them here, but because I'm not going to run through to save us a little bit of time, I'm not going to actually click create here. You give the layer name like LaunchDarkly Node. And then you're going to upload your zip file here, and then you're going to choose the runtime, and you're going to click create. It'll take a few moments to create that for you, but then once you do, you can then go into your Lambdas. So we're going to start. We have the Lambda we're going to work with here, which is this devops.com demo Lambda. I've already actually added one layer for something we're going to use later, but I'm going to add this LaunchDarkly layer. I click add layer. I go to custom layers, and I'm going to choose this Node Dynamo one because we're going to hopefully get to using Dynamo in a little bit, given if we have time. Then you choose the version, and then I'm going to click add. We'll just give it a moment to add this. Usually it's really quick. Okay, so now we've got that layer added. And what that means is that's all I need to do to be able to use LaunchDarkly within my code here. Obviously, this works for more than just LaunchDarkly, so I recommend checking out layers for managing a lot of your dependencies. It's a really useful tool if you're not already using it. So, okay, that's really all there is to layers. I'm going to kind of continue on with some more. All right, so now that we have LaunchDarkly in our Lambda, what we want to be able to do, obviously, is get flag values out of LaunchDarkly. And to do that, we call like these different flag values, we call them variations. In this case, the code for this is pretty simple. I'll show you how to instantiate the client, but you're just going to pass the flag value here, the name of the flag. You're going to pass a context, well, I'll explain a little bit later, and a default value, and we'll talk more about that. Let's actually dig into the code. So in the repo, this is the first one here. If you notice, if you go through this repo, I've got two different versions of each of these, because one is actually if you're familiar with JavaScript, one is in common JS format and one is in ES module format. newer runtime, the newer node runtime kind of defaults to this ES module format. So that's why I kind of converted all the examples to that for you. Okay, so we're going to obviously import the node SDK. Then we're going to initialize the client with our LaunchDarkly SDK key. Let's see how we get that. If we go into LaunchDarkly, the easiest way to get that is actually from here. I can press Command or Control K. I'm going to go copy my SDK key for this environment. For the Node.js environment, it's going to be the server-side key. We have different keys depending on the type of environment you're running in. Because, for instance, for client side, we handle things differently to manage security, like in the browser, as an example. Whereas server side is going to be a little bit different, of a more secure of an environment. So I click that, and it's going to copy that to my clipboard. I'm going to go over to my Lambda. I'm not going to actually do this because then you'll see my SDK key, but you're going to go to environment variables and create an environment variable with that SDK key for this. Okay, so now we've got the SDK key set. Now we can initialize the client. This function here just waits to make sure the initialization is done so that we're ready to get flag values out of LaunchDarkly. And then you notice we're doing all of this outside the handler. We only want to run this once when the Lambda starts up. We don't want to run it on every invocation. So we're handling this outside. We're running that outside the handler. Within the handler, we are going to create a context. A context is how you tell LaunchDarkly how to target a flag. We're going to get into more advanced targeting. In this case, I'm just kind of sending a generic context key, which is it's going to use to determine that. And I'm doing that just basically saying everybody's going to get the same value. So if that flag is on, you'll see it true. If that flag is off, you'll see it false. And then what I'm going to do is I'm going to get the client variation. I'm going to use the client that we instantiated. I'm going to get the variation. I give it the flag key, which if we go back into LaunchDarkly, whenever you create a new flag, so this is my test flag. I just give it a name. It's going to create a key for that flag. Just one thing to point out here, flags are not just Boolean values. Flags can be strings, can be numbers or JSON. These are great ways to pass configuration down to your application that you can modify via flags and targeting. These are what's called multivariate flags, because obviously a Boolean can only have two values. Any of these can have any number of values that you can target however you like. So that key would get created when I create the flag, and I would basically just click here to copy it and paste that into my code. I need to pass it this context, which is the one I created here to tell it how to target. And then this last value is a default value. And the thing I want to talk about very, very quickly here is that one of the first questions I tend to get asked is, well, what happens if I can't reach LaunchDarkly, or LaunchDarkly happens to be down for a moment? And we have multiple layers of protection involved to ensure that your application will still work. The first is that as soon as we instantiated this client, LaunchDarkly actually gets all the details it needs to evaluate flags and keeps those in memory and an in-memory cache. And actually, from then on, when you call LaunchDarkly, it will actually use the in-memory cache to serve flag values. And there's a streaming connection open that basically updates. If you update a flag, it'll update in-memory cache. So if for some reason it couldn't communicate with LaunchDarkly, it's going to use that cache, and the browser is going to use a local storage. So there's different caches depending on where you're running, but it's going to use that cache in the first case. But if for some reason this client is initialized and it can't reach LaunchDarkly for some reason, this is a default value so it's going to say, okay, if I don't have a cache and LaunchDarkly is unreachable, I can use this value. So basically, you have these multiple layers of protection, so your application is not going to break. Just to point out this, I've actually flushed the client because this is all for like examples for testing. You do not need to flush the client here, which basically sends all the event data back to LaunchDarkly. So LaunchDarkly has lots of metrics about how your flags are used, like how frequently, when was the last call. It gives you all kinds of things in the dashboard. that you can use, and that gets sent periodically. So I'm actually just, in this case, forcing it to go. That's all I'm doing. So typically you would not include that in your code. So I'm going to go ahead and we're just going to show you that how this all runs here. So we've already installed LaunchDarkly via the Lambda layer. Now we should just be able to test this. And we're just going to run this test here. Okay, so you can see that all I'm returning is true, because in this case, I am not, all I'm doing is taking that flag value and passing it back to the body. So we can see that we are getting the correct values, because example flag, as you can see here, is on and it's serving true. In your applications, you're not going to just return the flag value. What you'd want to do here is actually, okay, based on this flag, we're going to basically choose different code paths. If this is true, we're going to run maybe this code we're testing. If it's false, we're not going to run that. We're going to run different code. So basically, that allows you to have code here that is only running if that flag is turned on. All right, let's go back to my slides. All right. All right, so now that we did the simplest getting a basic flag value here. And I will actually pause for a moment just to kind of mention, if there's any questions, please put them in the chat. And I know Wally is going to jump in and ask them when necessary.
Yeah, Brian, I think there's one question that may be good to take a pause in here just before you jump to the context. There are questions about the I think this is specific to the Node.js, perhaps, or JavaScript. Can you use the global config objects and define it in the Lambda layer itself?
Good question. I actually don't know.
Yeah, same here. I don't know, but we'll take that. If I find the answers, I'll let you know. But yeah, same here. Not the JavaScript developer, so I'm a little bit limited to that. That's fine. Thanks so much, Brian.
That's a good question.
Yep.
Yeah, that is a good question. You may be able to. There are different times where you might configure it differently on different Lambdas, so it's possible that there may be cases where that's not a good idea if you can. But I will look into that as well. All right. So I wanted to talk a little bit about context. So to do that, I want to mention that until I think it was about a month and a half ago, LaunchDarkly actually allowed you to provide a user object. And that user object represented everything you wanted to send LaunchDarkly that might be used for targeting purposes. And it was one giant object. It was also kind of confusing for people at times, because they mentally would think of it as a user, and that data could represent anything, didn't have to be a user. And it also didn't allow you to kind of deal with the complexity of how you might do targeting. So we added this idea of context instead of a specific user object. And what context does is it allows you to, it's similar to the user object, except that you can have multiple and different kinds. So the default one is going to be a user kind. And this is just a simple context object. I'm saying the kind is user. In every case, I have to pass some kind of key back to LaunchDarkly. And then I can pass whatever other data I might need that I might use for targeting, or for whatever reason I might want LaunchDarkly to know about this data. So like in this case, I'm passing name and email in this user object, but it could be any arbitrary data that I want added to the user. So, but it's important, again, to think of context as being something beyond just users. I might want to target devices or regions, and those are not actually users. Those are kind of a different context. So the user might be in their user context, but also be on a particular device that has a device context, and be in a particular region that has a region context. And I need to be able to handle that complexity of how I choose to target a particular flag. So in this case, I've created a device context that tells me, oh, we're passing to LaunchDarkly. Oh, by the way, this user is on an iPad and this is their OS, and so on and so forth. And I can actually use that data to target as well. So maybe the user here, maybe Anna is able to see a particular feature, but that feature isn't ready for mobile. So if they're on a mobile device, it actually is turned off. So again, you can have as many of these as you want. So you can basically, it's called a multi-context. You can send a single user context, or you can add as many of these as needed for your application. So perhaps, Anna belongs to the Global Health Services Organization, and I have some details about Global Health Services that I'm passing in as well. And maybe because Anna can see a feature, or and it does run on the iPad, but for some reason, we do not want this feature turned on for this particular organization. I can do that. And the important thing here is, even like, I've been building, for instance, and a lot of clients already do this, entitlements using this. So I can pass entitlements data, and we can actually target, like, manage, like, okay, Anna is on a pro account, and pro account can see these features and so on. So you can do really, really advanced stuff with context targeting. For my demo, we aren't going to do anything quite that advanced, but I'm going to show you a basic targeting, how targeting works, and how you can create a flag to target different users differently. We're going to do that by passing a JOT token that's going to be used as key, that's going to have the user information in it. So just for those of you who aren't already familiar with JOT tokens, they are a way of encoding data that I could pass securely via an authorization. I'm just using a simple tool here at jwt.io. JWT standing for JSON Web Token. And I'm encoding this data, which has some information about the user, and I have a secret key here. Actually, it reset my data here, but that's okay. We don't need it. I just wanted to show you this. I have a super, super secret key, but obviously you'd want to have this be much more secret than that. And then it's going to encode this. I'm going to pass this in the authorization header. So what I've done is actually just to kind of show you, I've created 2 different test events that simulate just passing header information with that JOT token in the authorization header. So we're going to go here into our code again, and we're going to do some user targeting and show you just some of the differences. Everything here in terms of initializing the client and so on is the same. The key difference here is I added in a little library here to decrypt the token. So I am then pulling from the event. I'm getting the authorization header. I've added a secret key to my environment variables as well that I need to pass to be able to decrypt that. So I'm then using that header to pass that information on to LaunchDarkly via the context. This is, again, still a simple single context user kind. And then I have this targeted Lambda flag, which I'm getting variations for. So let's look at that flag so you can understand a little bit and how targeting works. You'll notice that this flag is on already, but it's actually serving 2 different variations. So I'm currently serving you're an internal user or you're an external user, which are the 2 variations I have. And the reason for that is that by default, you're going to be an external user. But if you come in and you're in the segment I've created called internal users, you're going to get this variation called you're an internal user. Again, this is just a simple example, but this could be a different code path, or it could be I'm enabling a feature if for an internal user, but not an external user, just to kind of give you a sense of how that works. So in the segment section here, you can see my internal user segment. I've managed this by basically adding myself. So I added an individual target for me as the only internal user of this particular application. Typically, you wouldn't necessarily manage it that way. You typically add a rule that says, okay, based on this context data, add this person to this segment. But for this simple example, I just chose to do an individual user. So I'm just going to go ahead and copy this here so we can jump back into our Lambda. Just going to deploy that new code. Okay. So what we're going to do is I have two different tokens, one for the internal user, one for the external user. So if I try external user, you'll see that I am getting that variation because the email that was passed does not match my email, which is the email in this case is my key. And if I'm an internal user, the same code will tell me that I am an internal user. So yeah, as I said, you can get very advanced with targeting, and this is where the real power of LaunchDarkly comes in. But I think obviously this is just to kind of give you a basic sense of how all of that works. All right, so looks like I have a few minutes, and I want to get into one last demo for you. So as I mentioned, LaunchDarkly has a bunch of integrations that with existing tools in AWS, and one of those is DynamoDB. And so I've created this. The last two, or demo 3 and 4 here, are both related to DynamoDB. This particular example here is you have to install this DynamoDB kind of extension the SDK. This is obviously the Node version of that to get the feature store. And then I need to configure the feature store within here. So I'm passing it a DynamoDB table as an environment variable. This could just be a string with the table name. This was just to make it easier to update. Then I create a configuration that I'm going to initialize the client with that has that feature store, and I pass that in and initialize the client like normal. Now, the really cool thing that happens as soon as that happens, remember I told you before that it's typically LaunchDarkly would cache that in memory. What it's going to do instead in this case is pull all the flag data it needs to evaluate flags and cache that in DynamoDB automatically. So this little function is designed to just update DynamoDB. And the way I would do that is as I go into, and I will get in, by the way, just as a side note, I'll briefly mention there are other ways to update DynamoDB. This is just one of the possible ways. So I have this DynamoDB table I've created here that has currently no items in it. I also created the function here, which DevOps. Okay. So I've created this function, and this function is exactly what you saw there. I'm going to go ahead and test it. It takes a few seconds to run because it is actually, for the first time, caching everything in there. And then we should be able to run this and see that all our flag data has automatically been updated. I don't have that many flags, but all of it's been pushed into DynamoDB. So how do I get this to consistently update whenever I update a flag? So what I want to be able to do is I'm going to go into here. I'm going to go into my integrations. We've got a ton of different integrations. The one I'm going to use for this particular case is a webhook. So I've added a function URL, which you can easily add in to your Lambda within AWS. And I basically create a new integration. I can optionally give it a name. I paste that function URL here. And then this allows me to say when I want this webhook to be called. So I can create rules to determine when that webhook is called. So if we look at my existing one here, it basically says you can have multiple environments. So in multiple projects. So this is my default project. If I'm in the production environment and any flag is changed, it's going to call that webhook automatically, and that will update DynamoDB. So now, very, very quickly, I'll show you how would I go about using that in my Lambda. So I'm going to go over here to the next example here, which is just showing you how to read. And this is the part that I think is really exciting because it's super easy. So I do need to initialize that feature store. I'm doing basically the same initialization that I did in that other function I just showed you. The one difference is when I pass the configuration into the client, I'm adding this little flag that says use LDD as true. And what that does is it tells the SDK client to essentially use that feature store as the source of truth for flag data. So it is not going to go to LaunchDarkly. It's just going to go to DynamoDB. And it's going to assume that DynamoDB has the most updated flag data. The rest of this function is essentially the same. That's basically all I need to do to say use DynamoDB instead of using LaunchDarkly to update that data. So one thing I want to add there is I'm going to go back to my slides just to show you, and then I'll touch on one last thing since we do have time. So I already did this. So we do have something called the relay proxy. The relay proxy is a much more advanced thing, and it's not really in scope for me to cover it here. But if you don't want to use a webhook to rely on a webhook to call this function to update DynamoDB, the relay proxy is going to give you a much more advanced option for doing all of this and more. And it'll automatically keep those things in sync. And basically, you can use the relay proxy to kind of keep, even if, like, say, you want to keep things within your AWS infrastructure, but also, like, if you have an internal network and you don't want these calls being made outside, you open a tunnel on your relay proxy to LaunchDarkly, and you can communicate everything via the relay proxy to get flag data. So basically, all of your Lambdas would talk to your relay proxy instance instead of talking to LaunchDarkly. So I did want to mention that. And one last thing before we go to questions is I want to mention. So I briefly touched on the event data with it that LaunchDarkly has about all of your flag info. And this is actually even particularly important if you're going to run experiments, because those experiments rely on data being sent back from your code. So the one thing I want to touch on briefly here is that you can. So as you may already know, Lambdas are ephemeral. They will be spun up and shut down as needed based on the activity in your application. So you can actually make sure that that event data is sent to LaunchDarkly by using this Lambda Insights extension. And then you add this function. There's lots of console logs here. The key point here is that I am flushing the client, which is needed for the Node SDK specifically, and then I'm closing the client. And then that will basically make sure that all of the event data is sent back. This flush isn't needed on all the SDKs. It is needed on the Node SDK. So the way you go is basically the same way you would add any other layer. Oh, this is the wrong function, but so if you were to go in here, and I won't actually run this, but you'd add the layer like we did before, but instead of adding a custom layer, you're going to go ahead and choose this Lambda Insights extension and then add that to the function, and then you can do that. So simple little thing, but it's important to consider when you're running Lambdas to make sure that your event data is passed back. All right. So that's essentially it for my demo and for my half of the talk. We'll go ahead and take questions, but I think the key thing I want to just mention here is that, like, I'm a big fan of AWS. I think AWS offers just incredible, like, tools for building applications in a distributed way and building microservice architectures and all kinds of things like that. I'm a big fan of serverless in general, and of using AWS for that. And so, like, it's great to me that at LaunchDarkly you can use this within your serverless code and have the power of feature flags, but in a serverless manner. So hopefully that this has piqued your interest and you go ahead and check that out. All right, I'm going to stop sharing.
Thank you so much, Brian. That's a great demo, by the way. I love it. Very comprehensive, and I like how you put comments on the source code as well, so folks can come back to it and they still remembers pieces that you talk about. So I really appreciate that.
Yeah, thanks.
Yeah, Brian, there's a couple questions on the chat. Some already answers, but there's one that's really piqued my interest because today we talked specifically about serverless and feature flag, but I don't want people to forget, like, feature flag can be in many places, essentially, right? Including in your front end applications and etc. So one of these questions is about, say your application has multiple layers, like your front end, some middle layers, maybe some back ends and etc. How you typically see people using the feature flag? Is that like a one feature flag for all of them, so they kind of slice and dice it? Do you want to talk a little bit more about that, Brian?
Yeah. So thanks, Willie. So the thing that I'd say is it's important, as I noted, that you can use the same feature flag across all the different pieces of your application. So that feature, that one flag that turns on, say, the feature on the in the UI could also turn on the code that runs that feature in the back end of your application. And because you have the same SDKs that are all talking to the same LaunchDarkly instance, you can reuse that flag. Now, I would say that one of the cool things about a service like LaunchDarkly is it lets you do a bit more advanced control over that. So, for example, I can have what's called a prerequisite flag, right? So I could say, hey, this flag, if this flag is true or false or whatever value, right? Like this flag is true or false. Anything under it is a prerequisite of that flag. So what I would typically say is you could have a prerequisite flag that represents the feature as a whole, but then you can have sub flags like that allow you to control different parts of that feature rather than monolithically manage the entire feature as a whole. So you could say, this flag under that, it now controls whether the UI is on or off. This flag controls maybe what the code within my Lambda, and this flag is controlling some code that's maybe running on our internal servers. And so you have multiple pieces, and that way you can turn on or off any one of those pieces, and individually test those pieces without having to kind of flip on for everybody in it, because you're going to have different teams that are working on these different pieces. You want to be able to have that control, but then you want to be able to flip the entire feature on or off, right? So you have that prerequisite flag that says like, hey, if this, now that all those are ready, we flip that on and or we roll it out, or however we're going to do, like it turns on or off all of those features. So like if there's a problem, I kill all of those related pieces of code at once.
Nice. Yeah. I think one of the other patterns I pick up from your explanation is that you want to decouple the teams that managing those feature flag as well, right? You don't want to have one big feature flag that everybody is kind of stumbling on editing and try to enable or disable it, because at some point you may want to release the back end pieces of it ahead of the game before you actually release the feature on the UI itself, right? And you don't want to have multiple people sitting in the same room just to enable one flag, because you have a lot of that dependency. And the other part, I guess, Brian, any perspective on like the operational aspect of it? Because sometimes feature flag, you no longer use it, right? And you maybe want to delete it. Any perspective about like having many feature flag, or maybe just have one flags from that operational aspects as well?
Yeah, I mean, we tend at LaunchDarkly, we tend to use a lot of flags, and so I think there's different ways to deal with that kind of the cleaning up after some of these flags. So the thing I was mentioning before about metrics. So we do provide you metrics and actually surface up flags that you may want to remove because they're not being used. We have integrations like you can, if you integrate with, if you use GitHub, you can integrate with GitHub and see where the flags are in your code so that you can be sure like, okay, I need to remove this. Let LaunchDarkly will tell you, oh, it's in these places in your code. Make sure to remove it. So those are a couple of the tools, and it really depends on the cleanup part is also a lot of internal process to me. It's like we have to set up a way to handle doing, flag cleanup. So typically it's good to think about like the naming strategy to make it clear what that flag does, maybe who owns the flag or whatever other information you have there. Set a naming strategy so it's easier to identify, who owns a flag if you're going to have lots of flags and things like that. So and then it also could help you identify like some flags need to live long, and some flags are intended for cleanup pretty quickly. Like some flag I might release the feature's working. Okay, it's time to clean up that flag. Whereas another flag, maybe we're running experiment, or we're doing a slow rollout, or like where we're rolling out to different groups or rolling out to different percentages, and that flag has to live longer than the other flag, right? It's going to live for a while I'm doing that. And then there's other flags like those configuration flags, or something that manages entitlements, or something like that. Those are going to be permanent. Those are not going anywhere. So we need to be able to distinguish, like, hey, don't remove this flag. Okay, this flag is kind of like going to be a short-lived, like a kind of short-lived flag just for the feature, and those are kind of ripe for cleanup. And what we do internally is we basically have like a day, I think it's quarterly, that they set where the teams go and just clean up flags and do that. So there's a little bit of like both using the tools built into LaunchDarkly to help you do this, but also how you set up the processes internally so that you do that.
Nice. Thank you, Brian. Maybe we have one more time for one more questions in here. Brian, earlier you showed that the DynamoDB as data store for the feature flags. I think there's can be a twofold questions in here. One is that can we use other data storage apart from
Yes,
DynamoDB?
you can.
Was it?
You can. I know there's different. I'd have to look it up. I know you can use Redis as an example, but there's different options for the data store. It doesn't have to be DynamoDB. I just showed that because that is an easy example, and within AWS. But yes, you can.
Awesome. Great. And I guess the follow-up questions to that is that I think that's fit into the best practice in terms like how you use your feature flags. And can you maybe tell more about when you want to use data stores, and maybe when it might not make sense for you to use a data store?
So, I mean, I typically, when I'm talking about AWS, I like to set it up this way, because I think one of the things you want to do is you know every time, for instance, that Lambda gets spun up, it's going to make a call out to LaunchDarkly, and you're going to have like that stream that's going to update your flag data. And if you want to kind of limit the number of outgoing calls you have, so that, I think it makes a lot of sense, right, within this kind of architecture, to go ahead and use a feature store for that. And as you saw, like, it's pretty quick and easy to set up. So to me, it's just, there's no drawback to using that. But if I'm, obviously most of this applies to server-side code. So within like a backend code that isn't, say, running in a Lambda or on some, I may or may not do that. If I'm running it on my own server somewhere, this probably, like, I might not do that, because there's not really like a huge benefit, unless as I mentioned earlier, I need to keep it internal, like all the communication internal to my network, and I want to open up only that one channel. So I'd say, most of the time it probably isn't necessary in general.
Yeah.
But in my
I think,
opinion, but if you're in Lambda, probably, if you have multiple Lambdas, yes, you probably want to do it. Yeah,
especially if you're dealing with hundreds of thousands invocations, then you want to optimize like how you manage your traffic outbound as well, right? There's a lot of optimization you can do just on the Lambda handler itself and storing some of those environment variables, but this is, I think, beyond that as well, into like further optimization at scale. So that's great.
Exactly.
I know we have only 2 more minutes. Not sure if we have enough for last questions in here. But let's see if there's anything else we have on the key takeaways in here. I just want to make sure we're not missing anything. Kind of, there's a lot of great questions so far, so really appreciate that. Let's see. Yeah, there's a couple items around like a trial, of course. So if you are want to go ahead and try that, there's a couple handouts in here. So I really make a call out in here. So You can look at a couple of the handouts, and please download that. There's the trial for the LaunchDarkly. There's a 14 days trials. So combine that with the repo that Brian provided, then that gives you enough to get started with the Lambda. And a lot of these Lambda that Brian created, that's gonna fall under your free trial, free use on the Lambda itself. So it shouldn't incur you any additional charges as well. So again, and you can also find LaunchDarkly in the AWS Marketplace. So if you are now interested to kind of dip into more into like the enterprise feature of the LaunchDarkly after the free trials, we highly encourage you to look at it from the marketplace as well. Okay, we are at the last minute here. Brian, last final words from you?
Well, I guess reach out. I'm B. Rinaldi at launchdarkly.com. You can reach out to me there or find me on LinkedIn. If you have any questions, I'm always here to answer them.
Great. Cody, back to you.
Awesome. Thank you so much, Brian and Welly. I appreciate both of you jumping on here, sharing your expertise. And then, Brian, we really appreciate the demos that you ran through today. It was really informative. So thank you so much.
Thanks.
Thank you.
So I would at this point like to remind everyone that our session today was recorded. You will be receiving an email with a link to access the recording on demand, or you can also find it living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. It'll be there waiting for you. The 4 winners of our $25 Amazon gift card drawing are Gina G, Nash H, Paolo G, and Chris C. So to our 4 winners, keep an eye on your inbox to claim that gift card. It should make its way to you in about the next 48 hours. If you don't happen to see that gift card, just check your spam folder in case it got filtered out. I'd like to thank AWS and LaunchDarkly for sponsoring our program today. And to our audience, to you who has been watching and been hanging out with us for the past hour, thank you so much for spending your afternoon with us. We really appreciate you being here, and we want to hear your feedback. So as soon as we close out, there will be a survey that pops up. Let us know what you liked about our program or what you'd like to see on an upcoming one. Regardless, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day. And Welly, Brian, thank you both so much.
Thank you.
Thank you.